Hi guys, so today this is your first practice of doing video notes. So what we'll be doing today, we're going to talk about the theory of the plate tectonics, kind of bringing together what we've been talking about over the past couple of days, understanding the difference between mid-ocean ridges, and then today we're going to be talking about trenches and what that means for the ocean floor. So as we continue, when there is a subheading like that, you're going to add that, if you're doing the Cornell style notes, you're going to add that to the left side of your paper and just have it read deep ocean trenches. So what these are deep underwater canyons. How they're created, the ocean floor, when you have two plates colliding together, one of them is going to get pulled underneath. And we'll talk about why that is in just a second. So it gets pulled underneath back into the mantle. And so you see what I'm doing with my hands. When they come together, it creates this spot right here, this lowest spot. So when they come together, it kind of pulls down one and creates that giant canyon. That would be a trench. Many students would think that a trench would be where two plates are going away from each other and they leave a giant gaping hole, but that's not true. So it's when they come together. So trenches are the deepest parts in all of the ocean. And the deepest one is the Mariana Trench, which is 36,000 feet deep. To put that into some perspective, this over here will show you, first off, the Marianas Trench is right kind of nearby Japan. And this down here will show you if the Titanic is resting right now 12,000 feet below the sea level on the ocean floor. If you were to invert Mount Everest upside down into the ocean, it will go down 29,000 feet. So Mariana Trench is 36,000 feet below the surface. So that is quite deep. And you can see there are multiple trenches, not just the Marianas one, but there's others. Yeah, so again, this is how it's made when one gets pulled underneath the other one. So what does this is called subduction. This is a very important process. So again, when you have two plates colliding, one of them is going to be more dense than the other one. When continental and oceanic meet up, it's the oceanic one that's more dense, so it's the one that gets pulled underneath. So the heavier one gets pulled down because of gravity and its density. When it gets pulled down, this stuff here is going back into the mantle. As you can see in this picture here, that's going to get kind of recycled. It's going to melt and get back added into with the mantle to get reused again later. So new crust is made at mid-ocean ridges. We learned yesterday with the seafloor spreading, crust being made at those mid-ocean ridges, and now we know that crust is also destroyed at subductions, which makes sense because the earth is not getting bigger as new material is added. So when new material is added, old stuff has to get destroyed and recycled. So as far as subductions go, trenches are going to be the feature to look out for. So now we can pull all of this information together and create just one statement theory of the plate tectonics. So this is the most updated theory on how the crust is moving around the Earth. This is what replaced the continental drift theory. After we made some new discoveries, we were able to understand more of why the plates are moving rather than just continents drifting on top of the ocean floor, which is what Wegener believed. Okay, so this theory also will specifically include that the Earth's crust is broken into pieces called tectonic plates, and they don't follow any real true pattern. They don't follow along the coastlines because we know the ocean floor is also split, and we have different plates that run through there. So there's really no rhyme or reason. It kind of looks almost like a cracked eggshell. When the plates are moving, because all the plates are moving in different directions, they're going to bump into each other. They're going to go away from each other. They're going to slide past each other. And all of those affect each other in a different way. We're going to learn about those tomorrow. The theory was last updated in the 1960s. And basically, this states that the tectonic plates are in constant slow motion, so they always keep the same speed. And what drives them, what makes them move, is something called convection currents that are happening in the mantle, which I'm going to talk to you about on the next slide. So again, these are constant slow motion, nothing's going fast. In fact, the book pointed out that the plates move about the same rate as your fingernails grow. Pretty weird, I know. And in case you probably didn't know, your fingernails grow on average 1 to 12 centimeters per year. So no fast moving plates, you're not going to feel them move. They're very slow. Every plate does have its own separate rate that it travels. They can sometimes speed up and slow down, but they're not going to go anywhere near fast enough for you to feel it. Okay, so let's talk about these convection currents. This is something that you've experienced within your life. You just didn't know this is what it was called, which is the best kind of science. So this is exactly why the plates move, because we learned before that the mantle acts like a fluid. It's still semi-solid, so it's not a liquid layer, but it is pliable. It can bend. It can move. Remember that silly putty reference we talked about. So because it can move, that would cause the solid plates up on top to shift and move too. So what's causing them to move? In the mantle, the lower part of the mantle, it's nearest to the core, so it's going to heat up faster. Things on this planet, this is just a science phenomenon, warmer things are less dense. So warm water, warm air, it naturally rises. That's why in our building, if you've noticed, the 8th grade hall is always so much warmer than the freezing, ice box down in the 6th grade hall. In your house, the warmest room is probably your top floor, maybe attic space, and your coldest floor is going to be down in your basement. That's just natural. So hotter materials are less dense, so they rise up. But as they rise up towards the upper mantle, they're getting farther away from the heat source, which is the core, right? So they're going to naturally cool off. Cooler things are the opposite of hotter things, so they are more dense. So they will naturally start to sink down, in which case they're going to go closer to the core where they'll heat back up again, and now we have a circular pattern. It's a cycle. So it will warm up towards the core, rising because it's less dense, where it will cool off because it's farther away, and sink back down again. And then it will heat back up and rise and cool off and sink. And now you have a cycle. So this is what's going on all throughout the mantle. And to help you remember what this is in your notes, you're going to draw a picture. So to do this, I am going to do this. Okay, so in your notes, add this into your notebook. I have drawn our plates. These are the crust, the plates. We've got one over here, and then this one, that's going to be your subduction. So try your best to draw this. Okay, then I'm going to add in my mantle this part. We have our hot air rising up. And then we're going to complete our cycle with the cold sinking. cold air sinking, not air, I keep saying air, cold material sinking in the mantle. And then last we need to add in our core to remind us that that is our heat source. So tack on a little core at the bottom. Kind of looks like a frowny face, doesn't it? Okay, so that is what your drawing is going to be. Okay, last thing you're going to add into your notes. This is going to prep us for tomorrow, for your lab tomorrow. There are 3 different plate boundaries. So these are the different ways that plates can move positioned to another plate. So the first one is your transform boundaries. A transform boundary is when the plates slide past each other. They go back and forth. So like this one. That's your transform. Next one is the divergent boundary, which is this one here where the plates are moving apart. They're diverging from each other. And the last one is called the convergent boundary, which is both of these, and we'll explain why tomorrow. The plates are coming together or converging. So add those in your notes, highlight them, and then you'll be good to go for tomorrow's lab.